Hello everyone, good evening and welcome to the session. So I hope that everybody is fine and good health. So we have started this crash course, right? And we have already covered few sessions, and we had completed one topic, that is process synchronization. So we have completed part 1 and we will be covering part 2 today. So this session is a recorded session, okay? So this one today we are having a recorded session, and rest sessions will be live. Because of certain reasons I have to keep this session recorded, okay? So you, whenever you'll be watching this video, please join this telegram group if you haven't joined till yet. t.me/netreadigimento, this is the telegram link, and I'll be sharing this pdf today in this group only. ठीक है, जो आज की क्लास है उसकी pdf आपको यही मिलेगी. And I haven't sent previous PDF as well, that is the process synchronization part 1. So वो PDF आपको combined इसी session में आज मिलेगी. So after class I'll be sharing this PDF with you. And those who all who don't know me, my name is Ria and I have cleared both NET JRF and GATE. ठीक है, so if you have any query related to any exam, be it your JRF or be it your GATE or be it your NET, feel free to contact me. You can contact me via this telegram group only. And if you want to know about, or if you have any query related to the courses, then also you can call on this number 9821876104 or 9821876102. Ma'am will be there, she'll be contacting you and she'll be telling you and she'll be resolving all your doubts. You can also mail us at admin@gatelectures.com. so वहां पे भी आपकी कोई भी query है, so वो आपकी clear हो जाएगी. Okay, so these are the courses that you can see for NET. If you're talking about, depending on the months that we have, 3 months, 6 months, 12 months course. तो जैसे भी आपको feasible लगे, you can go for it. ठीक है, यहाँ पे आपको लाइव सेशंस भी मिलेंगे. ठीक है, लाइव क्लासेस भी हैं एंड रिकॉर्डेड क्लासेस भी हैं. सो रिकॉर्डेड सेशंस के जैसा भी आपको feasible लगे आप बाय कर सकते हो. एंड फॉर one subject you are having multiple teachers with you, so whatever you are having so many options with you, that एक subject के लिए there are so many teachers. So whichever you feel is you can connect with. Basically it all lies कि आप किस टीचर को समझ पा रहे हो, किस टीचर से आप कांटेक्ट कर पा रहे हो. ठीक है, तो जिस टीचर से भी आप कनेक्ट कर पाओ उसका वीडियो आप देख सकते हो. ओके, एंड यू हैव दिस कोड वेलकम 40. यू कैन यूज दिस कोड and you can have an access of any of the following courses. Okay, so it's for 3 months, 12 months, 6 months, and we have certain other courses as well, that is for your PGT, TGT, KVS है आपका, ISRO का एग्जाम है, गेट में आपका कोई भी कोर्स अगर आपको बाय करना है. सो सिंपली व्हाट यू हैव टू डू इज यू हैव टू विजिट दिस वेबसाइट digimento.com. okay, so www.digimento.com. so this is the website. Just you have to just simply visit this website and all you can access the courses over there. We have टेस्ट सीरीज एज वेल. ठीक है, मिनी टेस्ट सीरीज, मेगा टेस्ट सीरीज. तो उसमें नंबर ऑफ टेस्ट सीरीज टेस्ट हैं आपके. मिनी में आपके थोड़े कम टेस्ट हैं, मेगा में वी हैव मोर नंबर ऑफ टेस्ट. So if you are revising and if you have done your revision and you want to take test, go for the test series as well. ठीक है, we have this Android app as well, Digimento Education के नाम से है. So you can install this Android app. For now we do not have any app for iOS. ठीक है, we only have app for Android. We are planning and we are working on it for iOS as well. So right now all the Android users can install this app, and for the iOS ones I'll prefer you कि आप वेबसाइट पे चेक कर लो. ठीक है, वेबसाइट पे कोर्सेज को एक्सेस कर लो, वहां पे भी आपको इजीली एक्सेस मिल जाएगा. ओके, सो ऑलवेज लुक फॉर दी स्पेलिंग. Digimento Education इज योर एंड्रॉइड ऐप, एंड टेलीग्राम ग्रुप जो है दैट इज t.me/netreadigimento. ओके, तो ये आपका टेलीग्राम ग्रुप का नाम हो जाएगा. ठीक है, so in the previous class we have discussed this inter-process communication, then we have discussed independent process, cooperating process. ठीक है, हमने ये शेयर्ड मेमोरी, मैसेज पासिंग, वी हैव डिस्कस्ड एवरीथिंग. ठीक है, प्रोड्यूसर कंडीशन प्रॉब्लम भी हमने डिस्कस कर लिया था. सो व्हाट वी हैव डन, वी वर अबाउट टू स्टार्ट विद ये मैसेज पासिंग भी हमने कर लिया था. प्रोसेस सिंक्रोनाइजेशन वी हैव स्टार्टेड विद इट, राइट. वी हैव डन विद द बेसिक्स. sections of the process we have done, right? If you haven't seen this video, please do watch this video, because आगे की videos थोड़ी सी आपको हो सकता है समझ में ना आए, because you haven't seen the previous ones. Okay, then we have discussed this race condition also. Then critical section problem kya hota hai basically? So basic critical section problem says that there are three conditions that we have to meet, right? So critical section says that no two processes must be there at one time in the critical section, first point. And then there are three requirements that are there. Mutual exclusion. So mutual exclusion kya kehta hai? Mutual exclusion says that if this is your critical section, so in this critical section no two processes should enter at the same time. At the same time, at one point of time, if I'm talking about T naught, at T naught only one process should enter into the critical section. If more than one process is residing inside the critical section, this means that the problem is not mutually exclusive. Okay, so if process P is executing in critical section, no other processes can be executing in their critical section. So simple सा point है, एक time पे सिर्फ एक ही process critical section में होना चाहिए. Critical section here they are referring to as your CPU. Second point is progress. So second point is they are saying is that कि if suppose I am having two processes P1 and P2. Now if P1 and P2 are there and I have this critical section over here, now P1 does not want to enter critical section, ठीक है? P1 says that I am not interested in entering the critical section. Then P2 should enter. If P2 wants to enter, then P2 should enter. But P1 should not stop P2 from entering. Okay, what they're saying is that if P1 is there, P1 process does not want to enter the critical section. Okay, no problem. P2 is there that wants to enter the critical section. So P1 should not stop P2 from entering into the critical section. So this is your progress. So what they're saying, this solution is used when no one is in the critical section and someone wants in. Okay, then those processes not in their remainder section should decide who should go in a finite time. So basically what I have told you, they are saying simple thing that if P1 is not entering into the critical section, it should not stop any other process from entering into the critical section. So ये हो गया आपका progress. Third part is bounded waiting. So what they are saying is that every process is having a certain limit or certain bound to wait for the number of times it should enter the critical section. So एक limited number of time होना चाहिए for any process to enter into the critical section. So अगर कोई भी process है that is maintaining, that is fulfilling these three requirements, then we say that the critical section problem has been satisfied. Okay, so we have started with this Peterson solution. So what I told you about Peterson's was in this Peterson solution, basically what was all there, what we have discussed. I'll very quickly revise it all for you. So I told you that this is a very humble, what we say, humble solution. How humble we can say it? Because humble I'm saying because first of all, this Peterson is valid only for two processes. Okay, this Peterson solution is meant only for two processes. So this is the first drawback you can say for Peterson solution, that it is applicable only for two processes. So here they have referred to as Pi and Pj. So only when we are talking about two processes, or when we are dealing with two processes, then we can use this Peterson solution. Now what they are saying is that Peterson solution में basically what they are saying that if Pi is there, ठीक है, now Pi also wants to enter the critical section, ठीक है, what they are saying that process Pi also wants to enter into the critical section, but before entering critical section it will go to Pj and it will ask do you want to enter into critical section? ठीक है, what they are saying is that Pi wants to enter into the critical section, but before entering into the critical section it will go to Pj and it will ask Pj, do you want to enter critical section? If that is the case, similarly if Pj is there, ठीक है, this is a critical section and Pj is there and Pj is about to enter critical section, and what will happen before entering critical section, Pj will go to Pi and it will ask the same thing, do you want to enter critical section? If Pj says yes I want to enter, so Pi will wait and it will let PJ enter the critical section. And if PJ says no, I don't want to enter critical section, then PI will enter into the critical section. So what the first point is? The first point is it is a very humble solution. Humble means basically it's asking the other process ki agar if you want to go forward, you can go, I'll wait for you. This is what it is saying. Okay. Then we have two variables over here. We have discussed those variables also. I hope you have remembered these variables. First variable was a Boolean variable, flag, right? And the another one was integer variable, turn. Okay, so what flag will do? Flag will tell us that which process is ready to enter into the critical section, and turn will tell us ki which process turn, whose process turn it is to enter into the critical section. So this is what we will say, and turn will only decide, okay, if suppose if I'm saying that turn is equal to I, so this means that I is allowed to enter into the critical section. So what it will say that I is allowed to enter critical section. Okay, so you have to remember this key. Turn will decide ki which process will enter the critical section. If turn is equal to J, then it's whose turn to enter critical section? J is allowed to enter into the critical section. Okay, and suppose if I'm saying that flag of I is true. If this is the case, this means that process PI is ready to enter the critical section. Okay, if flag of I is true, that is flag of process I is true, this means it is ready to enter the critical section. But if flag of I is false, if it is false, this means that it does not want to enter the critical section. It is not ready to enter the critical section. So this is the basic crux of the Peterson solution. It is basically based on these two variables only, flag and turn. Flag basically will tell you which process is ready to enter, and turn will tell you whose turn it is to enter the critical section. I hope यहाँ तक बात समझ में आ गई होगी. ठीक है, ये हमने डिस्कस किया था इन प्रीवियस सेशन, सो दैट इज व्हाई आई वेंट अ लिटिल बिट फास्ट. अब वी विल बी डिस्कसिंग अबाउट द सॉल्यूशन. ओके, सो आई हैव टोल्ड यू आल्सो, मैंने आपको ये भी बताया था कि इफ आई हैव दिस टाइप ऑफ स्टेटमेंट while some condition is there and then I have this, so I told you that this statement is meaning what it is trying to say, that we have this condition, then we have this loop, there are certain statements, and then I am stopping this. So when I am having this type of statement, that is with while only I am having semicolon, it basically means that there are no statements inside this while. Okay, so until unless this will become false, I have to continue with this while. Okay, so let's start with the code. So this code is for your process PI. So what they are saying, do. So basically we are having do while loop. So what we are doing, do flag of I is equal to true. So what we are doing, we have this variable that is flag of I, and if you see they have written very clearly over here that a boolean array flag is initialized to false. So what is happening, basically initially the variables, that is the flag variables, are false. I is also false and J is also false. Okay, and what is happening, and we have this critical section with us. So this is the critical section. Now let's see what we have to do. So do flag of I is equal to true. So what I have to do is I have to change this false to true. So I did flag of I as true. Now what is the meaning of flag of I is equal to true? Flag of I is equal to true means that the process I is ready to enter into the critical section. Okay, now what happens now? Now what is happening is that कि दो process is ready to enter. ठीक है, process जो है आपका ready है enter करने के लिए, कहाँ पे ready है enter करने के लिए? critical section में. But what happened now? Process PI sent, did what? Now process PI is doing turn equal to J. Now what process PI is doing? Turn equal to J. So humble solution, right? अब प्रोसेस पीआई ने क्या किया, प्रोसेस पीआई ने टर्न दे दिया जे को. गेटिंग द पॉइंट. PI was ready to enter into the critical section. PI ने क्या किया, अपना फ्लैग किया true. But as soon as it was about to enter the critical section, उसने क्या किया, उसने टर्न दे दिया J को. ठीक है. अब क्या कंडीशन आई, while flag of J, ठीक है, and अब यहाँ पे क्या कंडीशन आ गई, एंड आ गया. सो आई होप यू ऑल नो कि इफ आई हैव कंडीशन 1 over here and I am using and then I am using condition 2. So if and is there, then both the conditions have to be true in order to make the whole condition as true. Yes or no? If I want कि ये पूरी condition, तो पूरी कंडीशन ट्रू हो, सो एंड आई एम यूजिंग एंड एज एन ऑपरेटर, सो इन दैट केस कंडीशन 1 भी ट्रू होनी चाहिए, कंडीशन ट्रू भी ट्रू होनी चाहिए, है ना. अब यहाँ पे क्या है कि while, अगर ये स्टेटमेंट आपका क्या है, ट्रू है, yes और no, यही बताया था. अगर ये स्टेटमेंट आपका ट्रू है, सो व्हाट यू विल डू, यू विल बी इन दिस लूप, यू विल स्टक इन दिस लूप. yes और no, ये बताया था ना. अब यहाँ पे क्या है, while flag of j, what is the value flag of j, flag of j है हमारा false. So what has happened, flag of j has become false, this is false, and turn is equal to j, ये वैल्यू है true, तो ओवरऑल वैल्यू क्या आ गई, false. ठीक है. so what is it, while now the condition is false. So while the condition is false, I'll move out of the loop or I'll stuck into the loop. What will happen? अगर कंडीशन ये है तो whether I'll stay into the loop or I'll move out of the loop, I will move out. Yes or no? अगर ये होता while true, ठीक है, एंड दिस, मतलब कि दिस स्टेटमेंट इज ट्रू, सो आई विल, अगर हम नॉर्मल वाइल की बात करें, ठीक है, इफ यू टॉक अबाउट नॉर्मल वाइल, सो दिस इज वाइल, ठीक है, लेट्स से i इज इक्वल टू 5 एंड देन आई हैव टू इंक्रीज वैल्यू ऑफ i बाय i प्लस 5 एंड देन एग्जिट. ठीक है. सो नाउ सपोज while i इज इक्वल टू 5 है, अगर ये वैल्यू हो जाए ट्रू, देन आई मूव इनसाइड दिस लूप एंड देन आई फॉलो इट अगेन. i की वैल्यू हो जाएगी अब 10, देन आई अगेन चेक, ठीक है, तो आई फॉलो दिस. बट अगर i की इनिशियल वैल्यू ही 6 हो जाए, सो दिस वैल्यू विल बिकम फॉल्स एंड आई कम आउट ऑफ दिस लूप. दिस इज व्हाट हैपेंस. सो अब अगर ये है कि while false, अब अगर हो जाए while false, so I will not go inside this loop, I'll just simply come out. So यहाँ पे क्या हो रखा है, यहाँ पे हो रखा है while false. So what will happen, जैसी कंडीशन false हुई, I will come out of this loop. ठीक है. अगर true होती तो I would have entered again and again. Yes or no? Right. So अब कंडीशन false हो गई. Now what will happen, now this is a critical section, now pi will enter into the critical section. Now what will happen, after exiting the critical section, flag of I will become false. So यहाँ से flag of I हो गया आपका false, correct. एंड देन रिमेनिंग सेक्शन, और फिर जब तक कंडीशन ट्रू है आप इसी लूप में रहोगे, और जैसी while की कंडीशन फॉल्स हुई, यू विल मूव आउट ऑफ दिस लूप, जो भी आपका आगे का प्रोग्राम है. ठीक है. तो ये हो गया आपका क्या, दिस इज योर प्रोसेस PI. नाउ व्हाट इज हैपनिंग, लेट्स टॉक अबाउट प्रोसेस PJ. ओके. नाउ दिस इज योर प्रोसेस PJ. सेम वर्किंग है प्रोसेस PJ की भी. ओनली डिफरेंस इज I की जगह J आ गया है, दैट इज द ओनली डिफरेंस. ठीक है. जहां पे J है वहां पे I है, जहां पे I है वहां पे J. सो दे हैव इंटरचेंज द वैल्यूज ऑफ I एंड J. अब अब you must be thinking कि what will happen if both the process PI and PJ start executing at the same time, because they both are different processes and they can execute at same time. So let's say अब हमारा क्या है कि let's talk about this turn variable. ठीक है, अब we have this flag of I. ठीक है, let's say this is your flag of I and this is your flag of J. So initial value of both of them is false. So initially they are false. So now what we are doing, we are checking what will happen if both of them, both the processes PI and PJ start executing at the same time. So what will happen, this will execute the first statement, flag of I is equal to true. So इसने अपना flag क्या किया, true कर दिया. इसने अपना फ्लैग क्या किया, फ्लैग ऑफ जे, इसने भी अपना फ्लैग क्या किया, ट्रू कर दिया. यहां पे क्या हुआ, टर्न इज इक्वल टू जे, टर्न की वैल्यू हो गई जे. एंड व्हाट विल हैपन नाउ, एंड यू हैव टू रिमेंबर दिस दैट टर्न जो है आपका, टर्न इज अ शेयर्ड वेरिएबल, राइट. टर्न क्या है आपका, टर्न एक शेयर्ड वेरिएबल है, मतलब कि शेयर्ड वेरिएबल मींस दैट दिस वेरिएबल विल बी शेयर्ड बाय बोथ द प्रोसेसेस. सो प्रोसेस आई ने टर्न की वैल्यू कर दी जे. सो अकॉर्डिंग टू प्रोसेस आई द वैल्यू ऑफ टर्न इज इक्वल टू जे एंड आफ्टर this executed, so turn will become what, turn will become I, since they are using the same variable. So once pi change the value of turn to j, and then what happened after that, j change the value of turn to I. Okay, now this condition will be checked while flag of j, so flag of j is true, this is true, and turn is equal to j, but turn is not equal to j, so this will become what, this will become false, right. So turn is not equal to j, this will become false. So this will move out of this loop, and inside the critical section process pi will enter. Okay, now we'll check this condition. What they are saying, flag of I is true and turn is equal to I. So turn is equal to I, this is also true. Now my entire condition becomes true, so I will be stuck into this loop. I will not be able to move out of this loop because the condition is true. So that is why now process PJ will not be allowed to enter into the critical section. I'll repeat this again. I'll explain this term again. ठीक है? See, try to understand. जिसको समझ में आ गया, they can skip this part, and जिसको नहीं समझ में आया, just give one more thought. Okay? So basically, what we are having turn as a variable. ठीक है? And turn is what? Turn is a shared variable. Okay? Then we are having two variables, flag of I, and we are having flag of J. Correct. And what we know is, we know that the initial value of flag of I and flag of J is false. So okay, these values are written as false. Now what will happen is, what I am trying to check, I am trying to check that if PI and PJ execute simultaneously. ठीक है, if they're executing one at a time, तो ठीक है, तो सारी problem sorted है. But if PI and PJ are executing simultaneously, then what will happen? Will there be mutual exclusion or not? This is what I have to check. What I'm checking, कि if both the processes are executing at the same time, ठीक है, मतलब one by one I'm executing these processes, then whether in critical section at same time two processes will enter or not. So basically I'm checking mutual exclusion. Okay, now let's start with PI. This is your PI and this is your PJ. So what we are doing, flag of I is equal to true. So with this statement what I did, I changed the value of this flag of I to true. तो ये हो गया आपका true. ठीक है, and then what I am doing, then I executed what, let's say पहले ये execute हुआ, फिर हमने ये execute किया. Let's say this, ठीक है, turn is equal to J, तो turn हो गया हमारा J. Now what I did, now I preempted my process. Preempted मतलब now I'll execute the process PJ. PJ says flag of j is equal to true. So flag of j की value was earlier false, now it will become true. turn is equal to I. Since turn एक shared variable है तो इसी value को change होगा, मतलब j will be overwritten by I. Now what we are doing, while flag of j, so basically this means that flag of j is equal to true. So what is the value of flag of j? Flag of j is true, correct. And turn is equal to j. अब turn की value तो update हो गई, turn's value has been updated by pj and it has become I. So this value statement becomes false. So entire condition becomes false, and जैसे ही condition false हुई, I will move out of this while. And what will happen now? pi will enter into the critical section. Now what we did, now we will execute this statement. While flag of I, so flag of I is true, correct, this is true, and turn is equal to I, correct, this is also true. So this means the overall condition becomes true. So as soon as the overall condition becomes true, it will go into the loop. So now that is why pj will not be allowed to enter the critical section. अगर if you would have changed the order of occurrence, मतलब what you would have done, पहले you would have executed turn equal to I and then you would have executed turn equal to j. So जो भी आपकी last updated value रहेगी उसको ही consider किया जाएगा. So this is very known to us that कि Peterson solution जो है वो mutual exclusion भी follow करता है, progress भी follow करता है. It is not the one process, it's not stopping the other process to enter, and एक bounded wait भी है. Bounded wait मतलब कि एक limited time के लिए आप एक process को रोक सकते हो, because you can see that as soon as critical section के बाहर pi आया, what it did, it made flag of I as false. Again it made what? Flag of I as false. तो अब अगर दोबारा कंडीशन आप चेक करोगे, flag of I क्या हो गया? Flag of I हो गया है false and turn equal to I है, तो ये हो गया आपका स्टेटमेंट. कंडीशन हो गई ये वाली false. Now you will move out of this loop and pj will enter into the critical section. Okay, so I hope this working is clear to everyone. अगर नहीं समझ में आई है working, ठीक है, if so I'll request you all कि दोबारा से इसको देख लेना वीडियो को, and still if it's not clear you can mention me in the telegram group, आप मुझे बता देना, and then I'll try to repeat this again. ठीक है. So it's very well written to us. To enter into the critical section, process pi first sets flag of I to be true and then sets turn to the value j, thereby asserting that if other process wishes to enter the critical section, it can do so. If both process try to enter at the same time, turn will be set to both I and j at roughly the same time. Only one of these assignments will last, the other will occur but will be overwritten immediately. The eventual value of turn determines which of the two process is allowed to enter its critical section first. So the last value है वो determine करेगी कि कौन सा process है वो enter करेगा critical section में. I hope this is clear to everyone. So Peterson solution preserves all the three conditions. Mutual exclusion is assured as only one process can access critical section at any time. Progress is also assured as a process outside the critical section does not block other process from entering critical section. And bounded waiting is preserved as every process gets a fair chance. So I hope ये point clear हो गया होगा. Peterson solution से question कभी कभी आते हैं, and there's one question in which they have asked, what they are saying is that they have given you the code. ठीक है, what they have done, they have given you this code and they have skipped one part. मतलब what they are saying, they have skipped this line. This entire line they have skipped. This while condition they have skipped, and they're asking you that what will be the correct condition for process pi. So you have to know कि अगर process pi है तो j की condition है, अगर process pj है तो I की condition है. तो ये याद रखना. Okay, if we are talking about process pi, we are using the condition for j, If we're talking about process Pj, we're using the condition for I. Okay, आई होप कि पीटरसन सोल्यूशन आपको क्लियर हो गया होगा, राइट? अब आया म्यूटेक्स लॉक्स. सो बेसिकली क्या है आपका कि आई हैव टोल्ड यू दैट जो आपका पीटरसन सोल्यूशन है, इट इज योर क्लासिकल, what it was written, क्लासिकल सॉफ्टवेयर बेस्ड सोल्यूशन. ठीक है, अब यहाँ पे what we have done now, we have entered the concept of locks over here. Now what it is basically, इसको हम बहुत डिटेल में यहाँ नहीं पढ़ेंगे, आगे पढ़ेंगे, बट I'll tell you. Mutex locks are software tools used to solve critical section problem. So Mutex जो है basically name, it is derived from mutual exclusion only. So this is mutual, and then we have this exclusion. So mutual exclusion. So from here we have got this term mutex. So the mutex lock is used to protect critical region, that is critical section, and prevent race condition. A process must acquire the lock before entering critical section. It releases the lock when it exits the critical section. The acquire function requires the lock, and the release function releases the lock. So we have two functions over here, acquire and release. So if you see, this is the basic working, as you can see over here. Do acquire lock, then after acquiring the lock you will enter the critical section, and after you have exited or you have taken an exit from critical section, you will release the lock. Okay, so we have acquire lock and we have release lock. Now we'll talk about semaphores. So I hope you all must have certain idea about semaphores, yes or no? What is semaphore according to you all? Though it is recorded session, but still let's try to make it interactive a bit, है ना? So what is a semaphores according to you all? So semaphore was proposed by Dijkstra in 1965, which is a very significant technique to manage concurrent processes by using a simple integer value. So basically this simple integer value is what? This simple integer value is your semaphore. So I can write it as that this semaphores are what? Semaphores are simple integer value. ठीक है, सो सेमाफोर्स में ऑब्वियसली यू नो थोड़ा बहुत आइडिया होगा आपको कि इंटीजर वैल्यूज होती है सेमाफोर्स, राइट? सो इट इज यूज्ड फॉर मैनेजिंग concurrent processes. So semaphore is simply an integer variable that is shared between threads or processes. This variable is used to solve the critical section problem and to achieve process synchronization in the multi-processing एनवायरमेंट. सेमाफोर से बहुत क्वेश्चन आते हैं, ठीक है, एंड बहुत सारे स्टूडेंट्स को प्रॉब्लम होती है सेमाफोर्स में ही. सो आई मेक श्योर कि वी आर एबल टू कवर दिस इन अ गुड वे एंड इन मोर व्हाट यू कैन से explainable way. Okay, so a semaphore S, apart from initialization, is accessed only through two standard atomic operations. So very well known to us that there are two operations. First is your wait and the second one is your signal. ठीक है, so wait को हम decrement भी बोलते हैं and signal को हम increment भी बोलते हैं. Okay, so now what is it basically? If you see, the wait operation was originally termed P. So you have to remember this कि wait जो है उसको आप P से भी denote करते हो, that is your proburn. From the Dutch proburn, that is to test. And signal को हम V से denote करते हैं, that is verhogen, that is to increment. Okay, so what we have to remember is that कि wait जो है it is denoted by capital P and signal is denoted by कैपिटल V, करेक्ट। एंड यहाँ पे जो इसको हम अप भी डिनोट कर सकते हैं, सॉरी इसको हम डाउन डिनोट डाउन करते हैं डाउन से, दैट इज योर डिक्रीमेंट, राइट। सो दिस इज योर बेसिकली डिक्रीमेंट एंड दिस इज फॉर योर इंक्रीमेंट, ठीक है। सो P और D, हाउ यू कैन रिमेंबर दिस इज PWD, आपने सुना होगा पब्लिक वर्क्स डिपार्टमेंट, है ना, एक आपने टर्म, ये तो बहुत कॉमन सी टर्म है, पब्लिक वर्क्स डिपार्टमेंट। सो PWD, सो दे ऑल आर रेफरिंग टू दिस डिक्रीमेंट ओनली। सो एक याद कर लोगे तो दूसरा आराम से याद रहेगा। सो PWD, दैट इज P, W एंड D, सो दे ऑल स्टैंड्स फॉर डिक्रीजिंग। सो क्वेश्चन में कहीं अगर P दिया है या वेट दिया है, सो वी नो दैट वी हैव टू डिक्रीज द वैल्यू ऑफ द सेमाफोर। सो हाउ यू विल रिमेंबर इट, PWD, पब्लिक वर्क्स डिपार्टमेंट से आपको याद रहेगा, ओके। ऑल मॉडिफिकेशंस, आई राइट इट ओवर हियर, तो आपको रिवीजन के टाइम भी सॉरी ध्यान रहे what terms we are using, what abbreviation or what short terms we are using, PWD. Okay, all modifications to integer value of semaphore in wait and signal operations must be executed indivisibly. मतलब when one process modifies the semaphore value, no other process can modify the same value at the same time. मतलब if I am saying that this is my semaphore S and there are processes P1 and P2, so at time t equal to 0, if P1 is decreasing the value of semaphore, then at the same time P2 should not update the value of semaphore. Okay, so what they're saying, when one process modifies the semaphore value, no other process should be allowed to modify the same semaphore value at that same time. So we have two semaphores, counting semaphore and binary semaphore. So counting semaphore can have any value from minus infinity to plus infinity, and binary semaphore are having values only between 0 and 1. Binary semaphores को ही we say as mutex. ओके, एंड बाइनरी सेमाफोर से ही ज्यादा आपके क्वेश्चंस आते हैं। सो बाइनरी सेमाफोर इज टाइप ऑफ बिट इंपॉर्टेंट एज कंपेयर टू काउंटिंग सेमाफोर, एंड इट इज अ लिटिल बिट मोर कॉम्प्लिकेटेड एज कंपेयर टू काउंटिंग सेमाफोर। काउंटिंग सेमाफोर सिंपल इजी है, आपकी कोई भी वैल्यू सकती है सेमाफोर की माइनस इन्फिनिटी से प्लस इन्फिनिटी तक, और फिर आपको उसमें अपने वेट एंड सिग्नल ऑपरेशंस परफॉर्म करने। वील सी इट हाउ डू वी डू इट, ठीक है। सो लेट्स स्टार्ट विद काउंटिंग सेमाफोर फर्स्ट। Just give me a minute, okay? I'll just give me a minute. Yeah. Okay. So counting semaphore, as I told you, that the range lies from minus infinity to plus infinity. Okay, so it can have any value. Now how, now there's one term, one question you must be thinking ki, how do we decide the value of semaphore, hai na? If you think that okay, semaphores can have any value from minus infinity to plus infinity, then on what basis will we decide the value of this semaphore? So counting semaphore can be used to control the access to a given resource consisting of a finite number of instances. The semaphore is initialized to number of resources available. Very, very important point. In counting semaphore, if I'm saying, suppose that I'm saying that there are 10 resources available, okay, and then there are 5 down operations and 6 up operations. What will be the final value of semaphore? What I'm saying, a question can be asked in such a way as well, that there are 5 resources and there are 5 up operations performed and then 6 down operations performed on the semaphore. What is the final value of semaphore? Now many of you will be thinking that initial value तो हमें दी ही नहीं है, ठीक है, हमें क्या दिया हुआ है, हमें दिया हुआ है number of process, then they have given us up operations and they have given us down operations, and they're asking the final value of semaphore. So how we'll do it? This is a wrong question. You must be thinking. You will think, many of you will think like this only, कि there is no proper information given to us. But no. This number of process only is what? This number of process is equal to the initial value of your semaphore. ठीक है? So अगर mention नहीं भी है, so you have to know that कि semaphore is initialized to number of resources जो आपके पास available हैं. So very, very important point. Semaphore is initialized to the number of resources available. Each process that wishes to use a resource performs wait operation on semaphore, thereby decrementing the count. And when a process releases a resource, so basically जितने resources हैं उससे आप initialize करोगे, ठीक है? Number of resources, not process, number of resources कितने हैं उतना आपका होगा equal to initial value of your semaphore. ओके, सो व्हाट विल हैपन इज कि जब कोई प्रोसेस किसी रिसोर्स को यूज करेगा, ठीक है, व्हेन द प्रोसेस विशेस टू यूज अ रिसोर्स, इट विल परफॉर्म द वेट ऑपरेशन, इट विल डिक्रीज द वैल्यू ऑफ सेमाफोर, एंड व्हेन द प्रोसेस रिलीजेस अ रिसोर्स, it performs a signal operation that is incrementing the count. When the count for the semaphore goes to 0, this means that all the resources are being used. After that, process that wish to use a resource will block until the count becomes greater than 0. So value of counting semaphore may be positive or negative. Positive value indicates that the number of process present in critical section at the same time, and negative value indicates number of processes are blocked in the waiting list. So very important, अगर आपकी counting semaphore की value है +4, this means that in the critical section at the present amount of time 4 processes are there, ठीक है. Positive value indicates number of processes that can be present in the critical section at the same time, and negative value indicates number of processes that are blocked in the waiting list. ओके, सो रिमेंबर दिस पॉइंट इज वेरी इंपॉर्टेंट, क्योंकि आपको हो सकता है ये ट्रू या फॉल्स या फिर स्टेटमेंट से पूछ ले जाए, ठीक है. So wait operation will decrement the value of counting semaphore by 1, and signal operation will increase the value of counting semaphore by 1. ठीक है, if the value of counting semaphore is initialized with n, then maximum n processes can be present in the critical section at any given time. So ये भी सारे पॉइंट्स हैं, ये बहुत ज्यादा इंपॉर्टेंट है, प्लीज, ठीक है, इसको ध्यान से पढ़ना. If the value of counting semaphore is initialized with n, मतलब if I'm saying that value is 5, then this means that in the critical section at a given point of time, 5, maximum 5 processes can enter the critical section. ठीक है, सो अब तक आपको ये तो बहुत अच्छे समझ में आ गया होगा that what counting semaphore does not guarantee mutual exclusion. And why it does not guarantee mutual exclusion? Because at one point of time multiple processes can enter the critical section, and mutual exclusion says that only one process should be allowed inside the critical section. If only one process is there and the second process is not allowed to enter in the critical section, then we say that the processes are mutually exclusive. But here we have seen that more than one processes are allowed to enter at the same point of time inside the critical section. So counting semaphore will not guarantee mutual exclusion. Very 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 important point. ठीक है, ध्यान रहेगा. I hope this will, you will remember this point. So these points are very important from your exam point of view, so please take a note of all these statements. So this is one question given to you. A counting semaphore is initialized to 10, then 6 P operations and 4 V operations are performed on S. What is the final value of S? Try करो इसको. I'll give you 3 to 4 minutes for this question. It's very easy, but still try करो. So very easy, right? So what they are saying, that initial value is what? Initial value is 10. This means that how many resources are there? 10 resources, right? 6 P operations. Now 6 P operations means what I have told you. I have told you PWD. That is PW decrement. That is P and weight refers to decreasing. That means that how many weight operations are there to be performed? 6 weight operations. And 4 V. V means signal. That is 4, right? So what they have told you, they are saying that what is the final value of S. So we know that ki every time the value is decremented by 1 only, है ना? On every operation value is decremented by 1. So initial is 10. Then what we are doing, we are decreasing it 6 times. So we can say it by 6 multiplied by 1. We can like this. Plus we are increasing the value by 4 times. Okay, so this is plus 4 by 1. So it will be 10 minus 6 plus 4. So it will be 14 minus 6, that is 8. So the final value of semaphore turns out to be 8. Yes or no? चेक करो एवरीवन जिसका भी आंसर ये नहीं आया है. व्हाट इज द रीजन, क्यों नहीं आया, क्या गलती हुई है? मीनवाइल आई एम ब्रिंगिंग मोर क्वेश्चंस. ओके, तो ये एक नेक्स्ट क्वेश्चन है. आई जस्ट वॉन्ट एवरी वन ऑफ यू टू टेक अ स्क्रीन शॉट ऑफ दिस, ठीक है, एंड शेयर योर सोल्यूशंस इन दी ग्रुप, या फिर कमेंट सेक्शन अपने आंसर बता सकते हो आप लोग, ठीक है. एंड देन वील बी डिस्कसिंग इट टुमारो, जब हम लाइव सेशन होगा, टुमारो वील हैव अ लाइव सेशन, तो वहां पे वील डिस्कस दिस क्वेश्चन, ठीक है. आई जस्ट वॉन्ट एवरी वन टू टेक अ स्क्रीन शॉट ऑफ दिस. प्लीज टेक द स्क्रीन शॉट ऑफ दिस क्वेश्चन, ट्राई इट योर सेल्फ, ठीक है. यहाँ पे क्या बोल रहे हैं, अ शेयर्ड वेरिएबल x, तो x इज अ वेरिएबल दैट इज शेयर्ड, इनिशियलाइज टू 0, is operated on by 4 concurrent processes w, x, y, z as follows. Each of the process w and x reads x from the memory, increments by 1, stores it to the memory and then terminates. Each of the process y and z read x from memory, decrements by 2 and stores it in the memory and then terminates. Each process before reading x invokes the p operation, that is wait, on counting semaphore s, and invokes v operation, that is signal, on semaphore s after storing x to memory. Semaphore s is initialized to 2. What is the maximum possible value of x after all processes have completed the execution? So I just want you to give it a try. एक बार ट्राई करना इसे, ठीक है. अगर if nobody will share the answer in the group, अगर आई एम टेलिंग दिस वेरी क्लियरली बिकॉज ये हुआ है, अगर किसी का भी आंसर नहीं आया मुझे, आई विल नॉट डिस्कस दिस क्वेश्चन, एंड दीज आर द क्वेश्चंस दैट यू कैन एक्सपेक्ट इन एग्जाम, ठीक है. तो अगर इफ नोबडी विल सेंड मी एनी आंसर सोल्यूशन, बेसिकली आई एम आस्किंग फॉर सोल्यूशन, सिर्फ आंसर मत भेजना मुझे, अपने सोल्यूशंस भेजना, ठीक है. अगर नहीं आया किसी का सोल्यूशन, मैं ये क्वेश्चन डिस्कस नहीं करूंगी, ठीक है. I hope this is clear to everyone, ठीक है. Please take the screenshot of this. Okay, next we have binary semaphore. So now we have done with counting semaphore. Counting semaphore में क्या था? Counting semaphore says that value will go from minus infinity to plus infinity, right? So minus infinity से plus तक आपकी जाएगी, and negative value क्या denote करिए? Negative value is depicting that number of process in the waiting list, and positive value denotes कर रही है कि number of process in the critical section at a given point of time, ठीक है. जो PWD से आपको याद रखना है कि P stands for wait, that is for decrement, and rest SVD SVI जो है आपका, वो हो गया आपका इंक्रीमेंट के लिए, ठीक है. अब नाउ लेट्स टॉक अबाउट बाइनरी सेमाफोर. अब बाइनरी सेमाफोर की नीड क्या थी? व्हाट इज द नीड फॉर बाइनरी सेमाफोर? काउंटिंग सेमाफोर था हमारे पास एंड वी वर डूइंग इट फाइन. व्हाट वाज द नीड फॉर बाइनरी सेमाफोर? द मेजर डिसएडवांटेज of counting semaphore was it did not provide mutual exclusion. Yes, this was the major disadvantage of counting semaphore. So in counting semaphore, mutual exclusion is not provided, as there are set of processes which are required to be executed in the critical section simultaneously. However, binary semaphore strictly provides mutual exclusion instead of having more than one slots available in the critical section. मतलब यहाँ पे क्या है कि critical section में only one process can enter the critical section. There is only one slot. सिर्फ और सिर्फ एक slot है critical section में, and only one process at a time can enter the critical section. So instead of having more than one available in critical section, at most one process only can enter in the critical section. It is also known as Mutex lock. it can only have two values, 0 and 1. The value of binary semaphore is initialized to 1. Initialize कर देते हम 1 से. It is used to implement the solution of critical section problems with multiple processes. तो क्या points ध्यान रखने हैं? पहला तो इसको हम म्यूटेक्स लॉक्स बोलते हैं. फिर इट हैज टू वैल्यूज ओनली 0 और 1. इट्स वैल्यू इज इनिशियलाइज्ड टू 1. काउंटिंग सेमाफोर में हाउ डू वी डिसाइड द इनिशियलाइज्ड वैल्यू, इनिशियल वैल्यू? काउंटिंग सेमाफोर में इनिशियल वैल्यू इज डिसाइडेड बाय द नंबर ऑफ रिसोर्सेज, राइट. सो इनिशियल वैल्यू हो गई आपकी नंबर ऑफ रिसोर्सेज. और बाइनरी में क्या हो गया? बाइनरी में इट विल ऑलवेज बी 1. सो यू हैव टू रिमेंबर दिस कि इनिशियल वैल्यू कैसे डिसाइड की जाती है. ठीक है. नाउ नेक्स्ट व्हाट वी हैव, वेटिंग लिस्ट होती है. ठीक है. अब वहां पे भी काउंटिंग सेमाफोर में वेटिंग लिस्ट थी कि अगर नेगेटिव वैल्यू है किसी भी काउंटिंग, इफ सेमाफोर इज हैविंग अ नेगेटिव वैल्यू, दिस मींस दैट दीज नंबर ऑफ प्रोसेसेस आर देयर इन द वेटिंग लिस्ट. ठीक है. Similarly, in binary semaphore also we are having this waiting list. The waiting list of binary semaphore contains the processes that got blocked when trying to enter the critical section. In waiting list, the blocked processes are put to sleep. The waiting list is usually implemented using a queue data structure. ठीक है. अगर value of binary semaphore is 1, now what suppose they are saying is what कि value of semaphore is already 1. If I have to apply weight on it, I can do it. Weight क्या करेगा? Weight will what it will do? It will decrease the value by 1. So initial अब critical section में आपको जाना है and you are saying I have to apply weight. So what will happen is weight will decrease the value semaphore by 1. It will make it 0 and process will enter the critical section. This is what they are saying. If the value of binary semaphore is 1, the value of binary semaphore is set to 0 when wait operation is applied on it and the process is allowed to enter the critical section. ठीक है. So suppose यहाँ पे value है s की 1. What I am saying, I am saying wait and then you can enter critical section. So wait s means अब s की value क्या हो गई? S becomes 0 and you have entered the critical section. Now suppose s is equal to 0 and now I am saying wait. Now can value of s becomes -1 or not? सोच के बताओ, क्या s की वैल्यू -1 हो जाएगी? Will s will have -1 as the value? No, s will not have value as -1. S, if it is initialized, if it is value is having 0 and if I'm applying weight on it, this process, whatever process, suppose it is process I, this process I will enter the waiting list. ठीक है. अगर value of semaphore is already 0, okay, if the value of semaphore is already 0 and then you have to apply wait operation over it, it will not become -1. It will send that process to the waiting list. This is what is written over here. If the value is 1, it will change the value to 0 because what we are doing, we are subtracting -1 every time. ठीक है. -1 and +1 we are doing every time. So 1 - 1 will become 0. So it's okay. 0 is a value, valid value for semaphore, binary semaphore. 0 is applicable. So it will set the value to 0 and wait operation will apply or will be applied on it and process will be allowed to enter the critical section. But if the value of binary semaphore is 0 and then wait operation is applied on it, the process is blocked. Okay, and it is not allowed to enter the critical section. The process is put to sleep in the waiting list. So ये आपको ध्यान रखना है. अगर binary semaphore की value is 0 and then you're applying the wait operation, the process will not enter the critical section. The process will be sent to the waiting list. The signal operation is executed when a process takes exit from the critical section. There are two possible cases. If your waiting list is empty, the value of binary semaphore is set to 1. If the waiting list is not empty, a process is chosen from the waiting list and wake up to execute. ठीक है. Simple. अब ये क्वेश्चन है आपका. What they are saying, each process pi, I की वैल्यू है 1 to 9, is coded as follows. Repeat p mutex critical section v mutex forever. So p mutex is basically, I hope you all know, this is wait and v mutex is signal. ठीक है. So this is the code for 1 to 9. code for P10 is identical except that it uses vmutex in place of pmutex. What is the largest number of processes that can be inside the critical section at any moment? एक बार try करो इसको. I'll discuss this question here only. Okay. So see, अब तक तो आपने कर लिया होगा. So what we are doing is, what we will do first, we are having this process 1 to 9. ठीक है. So I'll just erase this, and we will write over here process, for process P10. So this is for process 1 to 9, and for P10 it will be something like V mutex critical section V mutex, right? So this is for P10. Now this, suppose let's say that this is my critical section over here. What they are saying, mutex means what type of semaphore it is? Semaphore is your binary semaphore, है ना? Now see, they have not mentioned anywhere that this is your binary semaphore. Only with the help of mutex I can say that this is my binary semaphore. Give me 1 minute everyone, please, just give me 1 minute. Yeah. Okay. So what we did, we start with process 1. Okay. So this is the value of mutex, that is the value of semaphore. So what I'll say ki okay, so this is the value of semaphore S, or they have mentioned mutex over here. ठीक है. So अगर कहीं पे they have not mentioned that whether this is your mutex or this is your binary semaphore. तो अगर mutex mentioned है, so make it clear to you that this is your binary semaphore. Okay. Now what is the initialized value of s? Initial value of s is 1. This is what we have studied कि binary semaphore में initial value क्या होती है? 1 होती है. So what we will do, we'll first talk about process P1. What will happen? P mutex. पहला statement है P mutex. So what will happen? P mutex क्या होगा? P mutex means I'll decrease this value to 0. And critical section. So P1 has entered the critical section. And what we did, we will just preempt this process from here. ठीक है, मतलब कि we are not taking P1 out from the critical section. Why we are doing so? Because we have to find कि largest number of processes क्या हैं inside the critical section. ठीक है. Now what we did? Now we took P10 after P1. What we did? We took P10. Just a minute. Yes. Okay. So what we did, first we will execute P1. Okay. And what we did now, we just preempted P1 till here only. It is still inside the critical section. Then what we did, we took P10. Then what we are doing, P10's first statement is V mutex. V mutex means to increase the value of the semaphore. So what it will do? It will do 1. Okay, it will increase the value of mutex. Now what we are doing, we are not letting it enter the critical section. We are preempting it till here only. ठीक है. अब इसके बाद what we did after P10, we took process P2. Now P2 is what? P2 is, again it will start from here only because P2 तो starting से start होगा. So P mutex. Let's talk about now P2. P2 is P mutex. So P mutex will again decrease the value of mutex to 0. And it will again enter the critical section. So P2 has also entered critical section. And then what we did, we again preempted it till here. Then what we did, we went back to P10. And what we did, we say okay, P10 can enter the critical section now. मतलब what, no, not critical section, sorry, P10. हाँ, P10 को तो हमने यहाँ preempt कर दिया था, right? P10 was preempted after executing the first statement. So we'll start with the second one now. And what will happen? P10 will enter the critical section. And then what we did, we took P10 out of the critical section and we executed V mutex again. So V mutex will again change the value of mutex from 0 to 1. And P10 is now out of the critical section. But P1, P2 are still inside the critical section. And the value of mutex is now 1. Now what we will do? Now we will take process P3. So P3 again will start from first. So P mutex, it will again change the value of to 0 and it will enter the critical section. Then again what we will do after this? Again we will execute P10. P10 will do what? It will do V mutex. It will change the value of to 1. Then what it will do? Again we'll preempt it till here only. We will take what? We will take P4. P4 again will do what? It will decrease the value of mutex and enter the critical section. Now what will happen? Now P10 will enter the critical section. And then P10 will come out of the critical section by increasing the value of mutex to again 1. So ऐसे करके सारे process एक एक करके they will enter the critical section one by one. So maximum largest number of process कितने हो जाएंगे? 10 process हो जाएंगे आपके. ट्राई करना पूरा, ठीक है? तो इसका जो करेक्ट आंसर आएगा वो आएगा none of these, because the largest number of processes कितने हैं आपके? 10 processes हैं जो एंटर कर सकते हैं क्रिटिकल सेक्शन में at any moment. ठीक है? सो इस क्वेश्चन को, ये इसकी एक्सप्लेनेशन है. ये जो आपके क्वेश्चंस हैं सेमाफोर्स के, ये ऐसे ही होंगे, ठीक है? वी हैव टू ट्राई बाय hook and crook. We have to apply every method to check कि कैसे हम इसको apply कर सकते हैं. How can we apply these methods and how can we know how we can preempt from any situation. ये हमें check करना है कि from which statement we have to preempt, and this will be done only with the help of practice. So tomorrow we will have a session on practice of process synchronization, जिसमें हम यही टाइप के क्वेश्चंस प्रैक्टिस करेंगे, ठीक है? टाइम मैं आपको ग्रुप पे मेंशन कर दूंगी. आज आप ये वीडियो देखो, अच्छे से पढ़ो, अच्छे से समझो सेमाफोर्स को क्या है, बिकॉज द एंटायर प्रोसेस सिंक्रोनाइजेशन इज बेस्ड ऑन दिस कंसेप्ट ओनली. ओके, इफ यू हैव एनी डाउट फील फ्री टू कॉन्टैक्ट मी, एंड कुछ भी पॉइंट ना समझ में आए सो यू कैन मेंशन इट ऑन द टेलीग्राम. आई विल ट्राई माई बेस्ट टू मेक यू एक्सप्लेन अगेन टुमारो. ठीक है? सो दैट्स इट फॉर टुडे. थैंक यू एवरीवन. टेक केयर. बाय बाय.